Hey everybody, thanks for completing the activity. If you haven't already, go back to Monday's activity, do that first, and then come back and watch this video. So we started off with just finding some areas of some rectangles, which you guys did awesome with. The big thing I want to point out there is how do you find that area, which the student already told us, length times width, as many of you know. And then you guys did it with this one that I split up into some kind of sections. Which then there was this one, which I actually had a typo on. This is not 49. This should have been 54. So if you guys would, will you go into this current activity and I change it to be 54 and show what the new area should actually have been there, so then it would line up with the square. So take a minute, pause this video, do that, and come back. All right, so what you should have gotten was 16 units, and then it'll fill in the square all nicely there. So then kind of the same thing, if you'll pause this video, based off of that, if this area of this orange square is 16 units, how long would each side have to be? So pause and answer that question. All right, that should have been 4 units long, and then those should have grown to show you that correct one. So that was a typo on my end. My bad there. I know that threw a few of you guys off. The big idea with that, kind of moving towards this one, is if you know the area, you can find the dimensions, and if you know the dimensions, you can find the area. So going back to these ones here, if I know the area, or the length was 4 and 5, I can multiply them to get the area. But if I took this one here and I knew the area of this was 16, I could also figure out that this was 4 by 4. So then going into this one here, it asks you to write the dimensions of this. And here's 2 ways that some students did that. The dimensions were 2x plus 3, which you can see the 2 x's here, and then the 3 1s, 1x there, and then the 2 1s there. And kind of similarly with this student over here. So then when you get to the area, here's some ways that some students showed that. We have 2x squareds, 1, 2, 3, 4, 5, 6, 7 x's. You could see this student here was counting them, 2, 4, and then 3 more make 7. And then 1, 2, 3, 4, 5, 6 1s there. But how do we know that this is x squared? How do we know those are x's? That comes down to the dimensions. If you look at this right here, that says that that's 1 long. So if we have a 1 by 1 square here, we know those are going to count as 1. If we look at this side here, this is x, and this is 1. So 1 times x gives you the x there. And then similarly with the blue squares, we have an x times an x gives you an x squared. So that's how you figure out what those areas are. Let's see. Forgot what I wanted to do next. Okay. So then that moves us into this here. I had you guys click on a couple of these and see that their graphs match. Isn't that wild? Isn't that crazy? Which you guys all noticed that there. So that's good. They're all the same. They're all the same, the exact same lines. And what that tells us is that those 2 equations are actually the exact same equation. So that's kind of what we were going over on screen 11 here. So on screen 11, there was a whole bunch of vocab words. So the first one is quadratic, and that's anything that has an x squared in it. So ax squared plus bx plus c, it could just be ax squared. So like anything with an x squared basically is a quadratic. And when you graph it, you call that a parabola. So this shape that you guys all graphed right here, except for that one, something got a little bit off, but this shape that all of you guys graphed right here, we would call that a parabola, and then these equations we would call quadratics. Now, I just said that a quadratic is anything with an x squared, but then I also said that this equation is a quadratic. I don't see any x squared there. That's because they're kind of hidden in 2 different forms called standard or factored form. Standard form is like that top one, where it's ax squared plus bx plus c. So let's see, sorry. So this top one here, 2x squared plus 7x plus 6, we would say that's written in standard form. Factored form is where you take it and you put it into those 2 sets of parentheses, as you can see there. And as we saw in that activity, the same thing can be written in two different ways. So that's what we're going to practice, is going from this form to that form and vice versa. Right now we're going to focus on going from factored to standard by a process called expanding. In next week's activity after spring break, we're going to go from standard form to factored form. So before we move on to screen 12 there, using these vocab words here in your activity that you're working on now, there's two screens. One asks you to try to write an equation in standard form, and one asks you to write it in factored form. So just any standard equation and any factored form equation. So pause here, take a moment to do that. Okay. Then after you do that, if you go on to the next screen again, it's going to ask you to expand 3x plus 2. It should be a screen that looks like this. You can sketch there if you'd like, if that helps you out. So pause, do that, see if you can do it on your own, and then we'll do it together here. Okay, so if I have 3x plus 2, I'm trying to write with my mouse here, so please forgive that. I think you guys know, and if not, here's a reminder, that all you need to do is distribute that 3 into both. So you get 3 times x, which is 3x, and you get 3 times 2, which is 6. When you're trying to expand something like this, you're going to do kind of the same thing. So I actually prefer what student 2 did. Example 1, if that makes sense to you, that's fine as well. And then I have a couple more ways that your classmates showed how they did this as well. So they said, basically multiply those first two, multiply the next two, multiply the last two, and multiply those two, which this one kind of broke down a little bit differently, but they get the same answer there. So going back to that, if I were trying to do this one, I would go x times x, which they showed, right here, and x times x we already said is x squared. Then you do x times 7, negative 7, excuse me, which is negative 7x. And then we're out of things to take that first x to, so then we move on to the 5. 5 times x is 5x, and 5 times negative 7 is negative 35. After that, the last thing we have to do is combine anything that matches. So x squared and x's are different, and numbers are different from those as well. So the only thing we can combine, I'll get a different color here. The only thing we can combine are the negative 7x's and the negative 5x to get that negative 2x. And this would be your final expanded form. Okay, so in your activity, the next question that it asks is, what did this student do wrong? And I will show you this student. This is our cat Dipper, by the way. He came to help me teach. So this student, this is their answer up top, this right here. And then down here is their work. They just made one minor mistake. See if you can identify that. So if you want to, pause and do that right there, that would be great. And then you can come back to this video when you're ready. Okay. And then at that point, I had you try one, and then we did this card sort. So following kind of those patterns that we look at here, let's start with this one right here. If x times x is x squared, x times 6 is 6x, 5 times x is 5x, and 5 times 6 is 30. So that's actually the part I'm going to look for first, is a 30, which I see right here. And then I just check, is 5x and 6x going to make 11x? They sure are. So if I were doing this one, I would check negative 5 times 1 is negative 5. So I'd look for that, which looks like it's right here. And then double check, is negative 5x plus an x give me that negative 4x? And it definitely does. So that's great. There are a few of these that are weird though. Like for example, this one. 10 times 10 times negative 10, excuse me, would be negative 100. So I look for that there. But I notice there's something missing here. I'm going to leave that as a question for you. What is 10x plus negative 10x? Think about that. kind of similarly with this one. Where's it at? Bet it's hidden right here. Yeah, this one. This one has a 2x in front that none of the others have, and that gives me a 2x there. 7 times 3 is still 21, but 7 plus 3 isn't 17. But if we back up a little bit and do it the way we started off, x times 2x is 2x squared, x times 3 is 3x, 7 times 2x is 14x, so 3x plus 14x is 17x, and then 7 times 3 is 21. Okay, so overall you guys did pretty well with this. I was pretty satisfied with what I saw. There was also this challenge question at the end. This is kind of leading into what we're going to do next week after spring break. The factored form of this should have been x plus 7 times x plus 6. Many of you got that, but if you still haven't got it, see if you can figure out how I knew that these were the factors based off of this equation. Okay, so now I'm going to direct you guys back to your activity. There is a one for you to try to expand, and then when you type in your answer there, it'll graph whatever you say is the answer. So you can kind of self-check there. They should match if you're right. Clearly not. And then there's one to see if you can try to factor, and same thing. When you check it in, type it in, it will graph it, see if you're right. Clearly not. Then the last thing, if you have any questions that you still have, anything you want me to know, or you want to share some plans for spring break, whatever, you can put it on that screen. If not, you're all done. Thanks for watching the video. Thanks for doing the activity. Have a good spring break.